Thank you for joining us for today's webinar, Digital Transformation for Transmission System Operators and Power Generation Companies. My name is Janne and I'm your host for this webinar. Let me start with a brief introduction to who we are. Some of you know us very well. Amitec has been working on digitalization projects for customers in the process industry for more than 25 years. We are based in Norway, but operate today as a fully digital company providing services to customers all over Europe. We are 30 employees, mostly covering the area of software and analytic engineers. We work very closely with partners and customers. We have been a partner for OSI, now Aveva, since 1996. I know there are several representatives from Aveva with us today, so thank you for joining, much appreciated. Dimension Software from New Zealand is also a partner we've been working very closely for the last couple of years. The company behind the product Asset Intellect, the enterprise visualization solution that is a part of the digital transformation for both Fingrid and AGL, the presenters today. Dimension Software is therefore co-organizing this webinar together with us in Amitec. We have several representatives from Dimension with us today, and they will be happy to answer any questions you may have during and after this webinar. Just a short run-through of today's program. I see that my time is up soon, and we'll move on to Fingrid and kick off our first use case presentation for today. Amitec has supported Fingrid in their digitalization journey since 2011. Back then, the focus was on condition monitoring using SCADA data. Today, Fingrid is using IoT in their transition into condition-based maintenance. We are very aware that many other companies are looking to implement IoT solutions similar to Fingrid's, and this is an opportunity to share and earn from the work that Fingrid has done. I hope that was an okay introduction to you, Janne, and your team, Marcus and Eero. Please start your presentation when you are ready and take over the screen.
Thank you, Jan-Erik. All right, good morning everyone online. My name is Janne Lappi. I'm working for Fingrid in our digital monitoring project. I've been working for this project for 2 years and 7 years for Fingrid in total. And now I'm going to make a presentation about this project that we have been doing together with many partners, including Amitec and Dimension Software. All right, great. Digital monitoring of high voltage substations. That's the topic that I'm going to talk about now, and it's also called the IoT project, Internet of Things project. The agenda for this presentation is as follows. First, I'm briefly going through the background and the business motives behind this project. And then I'll review the Internet of Things concept for our remote monitoring. And then I'll show you the situation where we are now, the project roadmap and the different use cases that are included in the concept. And then Asset Intellect, the end user interface of this whole system. I'll show you how Fingrid is using it, and finally I'll make a quick demonstration of the user interface. All right, let's have a look at the past regarding asset management in Fingrid. First of all, the reliability rate of the transmission network in Finland is very high, something like 99.9998. Anyway, very close to 100. So there is not really much to improve in that sense, but when we look behind the scenes, what's really happening in the substations, we have type defects in equipment, and that they have resulted in expensive repair projects because we may not have detected those emerging failures early enough. And then from time to time we have equipment explosions, mostly circuit breakers or instrument transformers. And that kind of explosions are dangerous for people and also for the surrounding equipment. And if there is some bad luck, it can lead to a chain of events which results in very high repair costs and a lot of work for sure. And if there's a lot of bad luck involved, then we'll see the effect of these events in that reliability rate number. Then condition estimates for refurbishment programs. In asset management, you never have enough resources to do all the maintenance you would like to do. So you need to prioritize. You need to choose where you spend the money in order to gain the best benefit out of the spent money for the maintenance. And so far that prioritization has been done based on some data and the expertise of specialists, but anyway, it's more or less the best guess. It's not based on real facts and real data completely. And making good decisions in this, it will become more difficult and more important in this decade as because the transmission system operators like Fingrid are very important actors in the field of climate change mitigation. We need to connect all the new renewable production that is being built into the network, and that is making a lot of work for us during this decade and for in the future as well, for sure. So the resources are limited, and for the maintenance and refurbishment projects, the resources will be even more limited. So we need to carefully decide where to allocate the maintenance resources. So that's why most likely the way that we have been doing fine so far, that will not work perfectly forever. And the last bullet point, maintenance work is still mainly based on time-based averages. That results in unnecessary maintenance activities for healthy assets, and on the other hand, the time interval of inspections and maintenance is quite long after all, so we may miss some important faults. So we believe that with the Internet of Things technology and the digital monitoring, we will be able to understand the condition of our assets better in the future. So the objective of this project is to totally transform from time-based maintenance strategy to condition-based maintenance strategy. We are not looking forward to have additional solutions on top of the strategy that we have had conventionally. We are looking for a total change. Less planned outages as a result of better optimization of maintenance activities and prevent equipment failures. Those two things will ensure or even increase the reliability of the network and the substation equipment. So after all, the key thing here is to understand the condition of our assets based on data and not estimates and guess. All right, let's move on to the next slide, which shows the digital monitoring concept of Fingrid. On a high level, this project is divided into three main sections: the sensor solutions, cloud data platform, and the user interface. And Fingrid is working on those 3 sections in parallel all the time. And let's start from the sensor solutions. The main thing here is that we use low-cost technology for scalability. It's really important because we have a lot of assets to monitor, so the costs must be kept low in order to make the whole thing feasible. Wireless data transfer, that's modern technology. Sensors, fast and easy to install, and retrofitting. The retrofitting thing is a key feature of the whole concept. The lifespan of high voltage substations is something like 40 or 50 years. So we can't wait for new equipment coming with the renewal projects of substations. It will not work. It will take too much time. So if we want to have good coverage on our substations with these monitoring solutions, we need to be able to retrofit the solutions into existing substations. And then here I have picked the 3 most important sensor solutions here, which I'll briefly describe. The first one, the yellow box there, is an IoT device for switchgear monitoring, meaning circuit breakers, disconnectors, and earthing switches. That's a custom development for Fingrid by our partners, because such sensor solutions were not available in the markets. So we had to develop that by ourselves. It's measuring current and audio from the switchgear with several sensors connected to the device. Then the next one is a simple out-of-the-box solution for temperature measurements wherever we find it interesting and necessary, but mainly for control building monitoring. We just want to make sure that our control buildings are heated or cooled properly during winter and summertime to maintain appropriate temperature in battery and automation rooms. But there are other use cases as well for these sensors because they are easy to install. So wherever we want to measure temperature, we just install that kind of small, cheap sensor. Then the third one, radio frequency interference sensors. The idea there is to measure the surrounding radio frequency radiation in the switch yard, because like that we can find partial discharges happening in high voltage insulation, which is basically relevant for instrument transformers, the current and voltage transformers. So when the insulation is degrading, the partial discharges are occurring, and with continuous measurements we think we will detect those events early, and we will prevent the explosions that I was talking about. That's briefly the sensor side. We are working with many partners on many different sensor development paths for each use case separately. But then what we have in the middle is the cloud data platform. The sensors are sending the measurement data wirelessly into internet in our Microsoft Azure cloud data platform. And there we have real-time processing of these incoming data streams. The analytic algorithms are analyzing the data in more or less real time from the preliminary data storage, and then the results of the analysis are stored in another storage, another database there. And we don't need to dive deeply into this IT architecture here, but to mention the most important component here is the red icon in the middle, the Databricks engine that is running the real-time data streams in which the analytic algorithms are working. So Databricks is taking the new data from the preliminary storage and running the analysis for the data and then storing the results in the SQL Server. And cloud solutions are good for this because they are easily scalable. Then the third section, the user interface. That's the end user tool for data visualization, and end users in this case means experts and mechanics at Fingrid. So the experts that are responsible for the life cycle of substations and specific asset groups, and also the mechanics that are working on site doing the maintenance, they will use this user interface as their tool for their work. So we visualize the data, we're trending the phenomena and trying to see some deviations, and the deviations will trigger alarms to appropriate responsibles that need to react to those deviations. And that third section here is the one that we're working on together with Amitec and Dimension Software. Okay, next I took a few pictures about the sensor installations to review these quickly. The first one is the switchgear IoT device installed in a disconnector control cabinet. It's there on bottom right, and then you can see various sensors are connected to that device, and the sensors are positioned all over the control cabinet. So the system is measuring every single operation that this disconnector is having over time. Then on the bottom we have that white color box is the radio frequency interference device. It's mounted on a pole in the switchyard, and the antennas are mainly directed to the direction of instrument transformers, but of course it's measuring the radio frequency radiation in all the surroundings. And then on top right we can see one small white temperature sensor attached on the primary parts of the disconnector to measure the temperature in the primary contacts. So if we have some loose contact or loose joint somewhere, we can detect the increased resistance by measuring temperature, because they tend to overheat in this situation. So these are the temperature sensors that I showed in the last slide. This one is actually a little bit custom developed for withstanding the high voltage environment in this case, but mostly it's an out-of-the-box solution. All right, and one key feature of the whole Internet of Things concept is that it's fully separated from the control and protection system of the substation. Here we have the substation on right here, and on the bottom below this dashed line we have the traditional conventional data environment of the substation, the automation system that is very robust and critical for the control and protection of the substation. So that's not something that we want to touch too much. So that's why the Internet of Things system is physically not connected at all into these circuits. It's a system on its own, and it's sending the data wirelessly to the cloud data platform, which isn't really connected to the SCADA system. So it doesn't make any danger to the data and to the data security of the substation. And the existing condition monitoring systems that we have had for many years is SF6 pressure monitoring and transformer DGA monitoring. And those solutions are inside of this conventional substation automation system. So now we have condition monitoring in both of these environments, the IoT environment and the conventional SCADA environment. All right, then where we are now in this project. Here it's the roadmap of the different monitoring use cases. I will not review all of them now here, but let's check the most important ones. Switchgear is the largest asset group in high voltage substations, and they are mechanical equipment, they require maintenance, and they have faults. So it all started from the switchgear use case. We developed those solutions, those sensor solutions, and the data analytics for many years. And now in 2020 and 2021, it's becoming quite nicely functional regarding both the sensors and the data platform and the analytics. So now we are about to start the rollout program to our stations. And now this slide says that we will roll out between 5 and 10 substations in a year, but we may want to accelerate that, because if we want to have a good coverage over our 120 stations in a reasonable time, that rate is not enough. So we may accelerate that rate. The second one is the partial discharge monitoring, the radio frequency interference monitoring. That was started much later, but in that case as well, we are also about to start the rollout to many stations with the sensor solutions. But the data analytics and the deviation detection algorithms are still in early stages of development, but we are working on it right now. Then the third one that I was talking about, substation building monitoring with the temperature sensors, that's pretty much rolled out already. We have our 120 stations covered pretty nicely, and those installations were done in 2020. Then, we have a lot of other developments going on, but let's jump here on the bottom to the data platform. First, we worked a few years to set up this whole data platform and the architecture and data pipelines in order to make the data flow smoothly from the sensors into the platform for further usage. Now the data streams are working quite nicely, so in the coming years we will concentrate on the analytics development, because the key here is to really understand all the phenomena that the new measurements will reveal us. So we don't really know what we will find out from the data. So once we have, or will have soon, a lot of new data, we will need to review that data and study it very carefully and decide what kind of approaches we need to use for the development of the analytics. Then the end user interface, we've had 2 proof of concept projects for that, and the second one was the one with together with Amitec and Dimension Software by using Asset Intellect, and that proof of concept was successful, and now that piece of software is in production as such. But of course, this whole IoT monitoring concept is in the transition phase from the development and innovation from to the production phase. But as a software, the Asset Intellect system is now in production in Fingrid. Then the last one, health index. I was talking about the prioritization of refurbishment projects of substations. In order to do that, based on all of these new measurements, we need to model the health of the assets and the substations. So we need to start the development of a new health index model that takes into account all of the new monitoring data that we have thanks to these IoT solutions. So that's a very, very big work that will take many years, because now we are starting to have the data, and then we learn what the data will show us, what we need to take into account when developing the health index, and that will change over time for sure when we learn new things. But anyway, that's something that we need to start working on now, so that we will have that ultimate goal of condition-based maintenance strategy in production one day. So that's a very interesting part that we will start this year. Here is just some nice statistics about the number of IoT devices that we have online. Right now we have around 1,900 IoT devices installed. And in the first trend here, we see the switchgear IoT devices, and that shows us that in the past we have had a number of devices which we used for development and testing purposes. But now at the end of since the end of 2020, we have started the rollout, and it's really showing here in the trend as the number of devices is increasing now, and that will become steeper in the future for sure. On the other hand, the temperature measurements of substation control buildings were rolled out mainly in 2020, and we can see the very steep curve here, which was the installation work that we did in a relatively short time period. And now we are continuing installations of sensors in the remaining stations that was left without sensors for some reason last year. And also we installed these sensors in another places than the control buildings. As I mentioned, there are other interesting places where we can use them. All right, then let's move on to Asset Intellect. The third section of the project, the user interface for data visualization. And that's very important for the whole concept, because this project is much more than just creating the sensor solution and data analytics. This project is about change management. We need to make people at Fingrid and Fingrid's maintenance contractors use this system in the future. It will change the way how they work regarding maintenance activities. So we need to have a very well working, nice user interface for the users, so that they want to use it and they find it interesting, because the whole thing doesn't work if if people don't want to use it. So this picture shows how we are using Asset Intellect regarding the embedded solutions. Here on the left we have the two kind of data that we have. The IoT data is stored in Azure SQL Server in the cloud data platform. On the other hand, the conventional condition monitoring data is stored in the PI system, in the PI data archive. And we want to use all that condition monitoring data together, and we want to analyze it together because the combination of the data will bring us valuable information. So we are using those two kind of data in the PI system, in PI Asset Framework and PI Vision. And PI Vision displays can be embedded in the Asset Intellect portal. On the other hand, we also have Power BI reports for the IoT data, because Power BI is good for some purpose, some other than PI Vision. So we can also embed those Power BI reports in the Asset Intellect portal, so that the user doesn't need to use these different solutions separately. And then any other custom URL, any other web page we want can be embedded in this Asset Intellect portal. And here we also need our asset data from our enterprise asset management system, which is Maximo. So the asset data is flowing from Maximo into the PI system, and it's in that way it's used in this whole system. And right now I will jump to the live demo session of our user interface. So our Asset Intellect portal is looking like this. We have a nice nice background picture in the main page, and on the left we have all our substations in that asset hierarchy, and we have a lot of content in the substations and the assets, and I'm really not able to show you everything, but I have chosen the most important use cases that we have been talking about in this presentation, so I'll show something about that. This display is currently the main display of Kymi substation, and this is showing the technical status of the different monitoring systems that we have installed there. Once we roll out a lot of new sensors, a lot of new technology in the substations, it's important to make sure that they work properly before we can make use of the actual data. So this is now showing the status of each monitoring system in different places in the substations. Let's ignore these pictures for now. They are still under development, as I couldn't find better ones there, but let's check some of these colors here. 110 kilovolt switchyard in this substation has the IoT switchgear monitoring system installed. 61 assets out of 63 assets are under monitoring in that system with 68 sensors. And it shows green, all the sensors are working and transferring their data into the data platform properly. In the primary circuit temperature monitoring, we have red circle here. There is some sensor that doesn't work for some reason. We need to investigate that. The same situation is in the radio frequency interference measurements in the 400 kilovolt switchyard. I know there is some device that has weak connectivity to the IoT gateway, so it doesn't send the data properly. So it's causing this red color here. So this is kind of an overview to the sensor solutions, to the monitoring systems. But then I'll show some other pages which visualize the actual data. So here we have navigated into the 110 kilovolt switchyard of that substation. And we are looking at all the disconnector and earthing switch operations that have happened in that switchyard. And from every single operation we have these statistic values that tell us information about the performance of those equipment. And if we have someone online that is familiar with the technical characteristics of switchgear, you might understand very well why we want to measure and calculate these things. So let's open one example of raw data. Here we can see the current profile of one disconnector motor operation. We see the current here, yes, nice, but we need to analyze this. So we have calculated the maximum current, the operation duration, and the energy under that curve. And these values are here in the table, so we can trend them and to see if they change over time when we have more and more operations from the equipment. Then also here on the right we can open the sound recording of that operation, and we here by clicking this audio widget we could listen to that sound recording and hear what the operation sounded like. And then we have some colors to pinpoint some deviations here, but those limits are still under development as we are rolling out the sensors and learning what the data can tell us. So these are not ready yet, but the functionality is there in this user interface. These are circuit breaker operations. We can see the trip coil current profile of the circuit breaker. That looks quite normal. And then all the values calculated out of that current. Then we have the charging motor operation, the current profile here as well. And it looks like everything is fine because the values are pretty much the same. The mechanical operation time is 37, 38, 37 milliseconds. It's all the same, so the equipment are probably working as they should. All right, then let's have a quick look at another substation called Korja and the control building there. Here we see all the temperature measurements that we have inside that control building in different rooms. The most important ones are probably this first one, akkuhuone means battery room, and this relähuone means relay room. So we don't want to have overheating of those spaces, and it shows green. It's the measurements are within the limits, so everything is fine. And on the left we have the water leakage sensors detecting any pipe breakdowns or whatever we can have in the water system of that building, and we have had no events so far in this building. So this is about the control building, temperature monitoring. Then the third interesting use case, one of the most important ones, is the radio frequency interference monitoring. So now we have navigated to another substation and 110 kilovolt switchyard there. And we are looking at the data from one RFI measurement device. And here we are overlaying the 5 latest measurements from the past 5 hours. And it shows how the radiation power is distributed over the frequency range between 100 and 1000 megahertz. And we can see that the curves are pretty nicely overlaid, so there hasn't been any change in the radio frequency radiation during that time, so probably everything is fine. Some of these peaks are caused by a telecommunications network or some other background noise. But here we will see the partial discharge patterns here when they happen, because different kind of partial discharges show in different ways. And we have some laboratory data, and based on that we know what to expect, but we haven't seen that yet because this monitoring system is so new for us. But we're sure that it will pay off over time. All right. That was what I was planning to show you this time, and I made it just in time, or 1 minute too late. So I guess that we have some time for a short QA session now, right, Jan-Erik?
Thank you so much, Janne. Maybe you should just leave your screen on if there is some questions that you could easily answer just using your mouse and visualizing it. Okay, Joni, will you take over the Q&A part?
Yes, yeah, I can, and thanks, Janne. That's a good presentation. And yeah, we got lots of quite interesting questions on different subjects. I think that the first one I'd like to pick from this is that how do you intend to do the analysis? Are you going to fully automate that, or do you have a team assisting you analyzing all this new data that you are getting in from IoT?
The ultimate goal is to have automatic analysis algorithms running in the cloud data platform that analyze the data and produce the trigger from the deviation and alarm to the experts, and then the experts can further investigate the data. So we are not really planning to have any team that will continuously monitor that data. But of course, during the development, we need to review the data manually and learn what the data can tell us, and then we can develop the algorithms to extract those features out of the data. But yeah, we will automatize this.
Oh, all right. And the another question is about when you are assessing the condition or the need for refurbishment, that do you also integrate to different history records or maintenance history when doing that assessment?
Yeah, for sure. We have all the fault history and the maintenance history in our enterprise asset management system in Maximo. So by integrating that system into this concept, we can make use of that data and take it into account in the analysis. And it's quite important actually, because if you repair a fault in an asset, after that it's probably healthy. So you may not want to have all the past data affect the health analysis of that piece of equipment anymore, because if there was a fault, it would still show some deviation for that asset if you don't erase that data before the maintenance activities. So yeah, it's an important part of this.
And is there any data currently coming in from the protection relays?
No, as I showed one of the slides, the whole IoT system is fully separated from the control and protection system, which means the relays and the automation equipment. So it's completely separated.
And I think that we have time for one last question here, which was quite interesting one, which is goes the goals of the whole project or what you want expect to get out of that, how far do you think that the condition-based maintenance can be extended with IoT when it comes to catching the failure modes? Do you think that you can ever catch all the failure modes, or maybe you can reduce the amount of manual inspection work required to understand the failures?
Well, that's a very difficult question. That's not really possible to answer that, but we from the past we know quite well what kind of faults we have in different kind of assets. So we are targeting these measurement and analytic solutions into those faults that we know already that they happen. So we are hoping to cover most of them, but for sure there will be something that we can't cover. Nothing works 100% sure.
So yeah, I think that we covered the questions pretty well here. So Jan-Erik, you have anything else here in mind?
Okay, Johnny, thank you. I think we'll wrap it up. So I'll just thank Janne and your team at Fingrid. We really appreciate your ability and the willingness to share your experience. Thank you to all attendees for your questions. As Johnny mentioned, we will follow up on any unanswered questions. Please also reach out if you have any further questions or would like us to organize a presentation or demo to dig deeper into the capability of Asset Intellect. And finally, thank you Dimension Software for co-organizing this event with us and for great cooperation during the Fingrid project. Thank you so much, everyone.